Good morning and welcome to the Nutrite Turfgrass 101, a three-part primer for turfgrass professionals. Each section that we go through will be about 20 minutes or so. I'm going to walk you through some of the important information that we have to offer. I am Mark Schneider. I'm a technical sales rep with the Nutrite Group. I'm going to talk a little bit initially about our company. We're a privately owned Canadian company servicing the retail, golf course, municipality, sports turf, lawn care, and specialty crop agri-producer markets. Our market includes Canada, the United States, Europe, Asia, Australia, New Zealand, Middle East, and more. We sell to over 20 different countries. Currently, we have over 100 employees across Canada and the United States. A little bit about who we are. Well, as it says on the left there, we offer sustainable, enhanced efficiency products. We're a trusted Canadian blend. We're a leader in a complete range of our fertilizer products, including granular, organic, liquid, and water-soluble blends. You can depend on us for proven, reliable, and innovative products that are developed with environmental, social, and economic sustainability, and for our nutrient stewardship as a key priority. We are a reliable and future-oriented company that meets the needs of turf and ornamental plant professionals by working to understand plant nutrition, thereby integrating this knowledge and technology into sustainable, enhanced efficiency fertilizers. Our personalized technical support and agronomic expertise complement your fertility management practices while optimizing field productivity and maintaining happy turf and healthy plants. What do we provide? Well, we offer the newest turf management technology, proven premium product performance, technical support by myself and other reps within our group, agronomic expertise, research-based product development, soil testing analysis and recommendations, a sustainable 4R nutrient stewardship, and our enhanced efficiency fertilizers. I'm going to begin with this, what we describe as the 360 degrees of managing turf. The number one thing that we try to do is try to understand what's in the soil. I'll speak more to that in a few minutes. The second thing, of course, is amend and improve our soil health based on the understanding of what's in the soil. Then designing programs that feed and supplement and to strengthen the plant. The fifth item there is review your cultural practices, irrigation, mowing, aeration, overseeding, and top dressing, and finally monitoring and managing control weeds, disease, and insects. This gives us an integrated, sustainable, environmentally responsible approach for healthy soil, plants, and obviously a healthy planet. We like to say it starts in the soil. This is a quote from the Home and Garden magazine, and it really describes the zoo beneath our feet. We're only beginning to understand soil's hidden world. If you look at the graphic on the left, you'll see sort of a 6-inch profile of what's really going on in the soil, with various invertebrates and vertebrates, a lot of microbial activity, and other things that we'll get into later on. What will we cover in these sessions? Well, obviously the factors that affect turf growth, a little bit about plant physiology, soil structure and texture, nutrition, obviously, and some site conditions, irrigation, and cultural practices and how they influence plant health. I'd like to start with this slide. What do we need to grow any plant? Really, if you look at the graphic on the right, you'll see the sun. This is really something that we learned in grade school. Carbon dioxide taken up by the plant, oxygen given off, water and nutrients taken up through the root system. If we were to look at or describe an ideal soil, what would it consist of? Of course, 30% water, 32% light, 33% air, and 5% food. Here are some factors that affect turfgrass growth. Light, the amount and duration, as you can see in the slide on the left, a very shady site. So obviously the turfgrass health is going to be quite limited. Temperature, both ambient air temperature and soil temps. Water availability, too much or too little. Airspace, both in the pore space in the soil. The soil type, texture, porosity, drainage, etc. And finally, traffic. These items were outlined in Dr. Beard's book, Turfgrass Science and Culture, in the early 70s. We'll talk a little bit now about turf physiology. What are the three main parts of the plants and what their functions are? Starting with the leaves and stems, and that's really sort of the area that we're dealing with for the most part when we're looking at a sward of turf. The second section there is the crown of the plant, really that joint between the root system and the shoot system, and the root system in underneath, which I described earlier, which will take up both water and nutrients. So we're going to start with some root hair functions. What actually do they do? Well, they anchor the plant and they hold it upright, of course. They absorb water and minerals from the soil and transport them to the stem and leaves. Another important function is they are able to store large quantities of plant food, basically the carbohydrates that are produced in that process. They also propagate and reproduce in some plants, and their growth is affected by soil temperature, moisture, and oxygen. Now here are the three main types of turf grass root types. The rhizomatous on the left, those are basically your bluegrasses, a bunch type like rye and some fescues, and then stoloniferous turf on the right, which is primarily the bent grasses used on golf courses and lawn bowling greens. Here's an example of some bunch type turf, some ryegrass that was on a soccer field that was suffering an extreme drought. As you can see, most of the other turf had faded except for these clumps of ryegrass that survived the drought conditions. Here's an example of a rhizome, which refers to mostly the bluegrasses that we deal with. In the middle of this, where my pointer is really the mother plant with the daughter plants coming off to the right and left through rhizomes that are underground stems that rise up a few inches away and start a new plant. Here's an example of a stoloniferous type. These runners that you see on the surface here would be running across the surface of the soil, and these, as I mentioned earlier, are part of the bentgrass family. So we're going to talk a little bit about the stems and leaves and what are their functions. Really, the primary function is photosynthesis to produce energy for the plant. They're also responsible for respiration, excess water out of the plant through the stomates on the bottom of the leaves here. They transport food and water upward and downward in the plant. We'll talk now a little bit about the crown and its function. It's the active growing point of the plant, junction of the stem and root vascular system, and it regenerates growth after damage to the leaves or the root system. You can see here a heavily trafficked area, and these light colored areas down below are the worn out areas that will actually regenerate from the crowns, and then you can see on the far right the recovered turf after some irrigation and inputs were put into the system. We'll talk now a little bit about soil composition. If we were to define what a perfect soil is, we describe it this way. If we were to take a cubic foot of soil, what would it consist of? 45% of that cubic foot would be mineral particles. 25% of that cubic foot would be air space. 25 would be water that's held within the soil, and the final 5%, as you see at the bottom there, is made up of organic matter consisting of organisms, roots, and humus. We'll talk now about some soil texture, and what it refers to is the weight proportion, relative proportion by weight percentage of sand, silt, and clay of the mineral soil separates for particles less than 2 millimeters as determined from a lab particle size distribution chart. So here on the left, we see the soil texture pyramid. This is done after you've sieved out a soil sample, and you can then, based on the percent of clay, silt, and sand, determine really where it falls in soil texture. If we start here on the left with the sand or the very high percentage of sand, as we add more clay and loam, we move into some of these other areas of clay, loam, and clay. Here's a very simple jar test that anyone can do if they're interested in what their soil texture is. By taking a small sample and putting it in a mason type jar, filling it up with a bit of water, shaking it vigorously for 2 to 5 minutes, and then letting it settle out for a day or two on a still surface, it will settle out into the various percentages of clay, silt, and sand. The one on the left, of course, would be a very high sand content soil. As you move and increase the clay and silt content, it moves over to loam, and then finally a clay soil would have more than 50% of its components as clay, with a percentage of silt and sand underneath it. Here's what we would do in the lab to determine what the sieve analysis is. There's a series of sieves that are vigorously shaken, so all the various particles fall into each different ring. Each ring has a different screen to it, and then by weighing each individual ring, you could determine basically what are the particle sizes, and you could then determine what your soil is comprised of. Now we'll move on to soil structure, which is different again than soil texture. It really refers to the arrangement of soil separates into units called aggregates. An aggregate possesses solids and pore space. They're separated by planes of weakness and dominated by clay particles. Silt and fine clay sand particles may also be part of an aggregate. If we look at the various profiles, if we were to dig down, say, a foot or two into the soil, we'd find these various horizons, starting at the top with the organic horizon, which is really undecomposed litter, partly decomposed litter, and decomposed humus. The second, or A horizon, is a humus cloud layer, glade, or waterlogged section. Moving down into the E, alluvial or leached horizon, and then deeper down we would find the B and the CR, or basically the bedrock underneath the topsoil that we're working with. Really, when you're growing turf grass, we're looking at anywhere, the horizon we typically deal with are between the O and the B horizon, to a depth upwards of 30 inches in some cases. So we're talking now a little bit about soil pore space. As it says, it's critical for proper growth. Air exchange really happens in these pore spaces, both upwards and downwards. Water infiltration and percolation upwards and downwards through the soil profile, and it has a great influence on nutrient uptake. The soil pore space, air pore space in the soil, you can see on the left by the graphic showing heavy compaction. This was an area that was outside of a mailbox in a condo development where dozens of people daily trafficked this very small area, and of course it was heavily compacted, even though it had an irrigation sprinkler right next to it. The way you would relieve that soil and overseed into it would be by using an aerator as shown on the left and introducing pore space into the soil itself to help it recover. And that brings us to the end of part one.